So we're going to split this section up into two sections. So we're going to stop after the second topic, law of sines. So just a little quick review. All these, you need to find out how many degrees are in each shape. So remember, that's n minus 2 times 180. Now hopefully you remember that a quad has 360, so that should be pretty easy. Notice we have a 90-degree angle here. These are both equal to each other, and this is 28. So our setup is 2x plus 90 plus 28. If you wanted to add those ahead of time, you can, equals 360. Okay, and so you're just going to add 90 plus 28 and get 118. That's an 8, believe me. You're going to subtract 118 from 360. 242, ahead of the game. And we divide by 2. You're going to get x equals 141. Or as they call it in St. Louis, 141. Okay, and that tells you the two angles, or 141, and you could check it. You could add 141 plus 141 plus 90 and 28, and you'll get 360. Now I'm only going to do one of these. Number 2 is similar because, again, you have x and x, and this is 90, so you're going to do it the same way. The only difference is there's 5 sides, so you're going to have 3 times 180, which means this is 540. On number 3, we have 1, 2, 3, 4, 5, 6 sides. So that's 6 minus 2, which means we have 720 degrees in the total shape. So in this one, again, this is 90. We have an x and an x, so that's 2x plus, and then you should start listing the numbers. 20 plus 90 plus 120 plus 140 plus 104. Now again, if you wanted to, equals 720. If you wanted to, you could add all those numbers up first. It really makes no difference. So 90 plus 20 is 110, plus 120 is 230, plus 140 is 370, plus 104 is 474. So 720 is equal to 2x plus 474. If you subtract 474 from 720, you get 246. So 2x equals, again, into 1, 246. And then when we divide by 2, we get x is equal to 1, 2, 3. Easy enough. Okay, into the new stuff for this. Use a calculator to find each trigonometric ratio. Round your answers to 4 decimal places. So this is simple calculator work. So we're going to take our calculator, and we're going to turn it on, and we're going to say tangent of 150. So remember, always make sure your mode is set on degree. And go back with quit. Tangent of 150 equals 0.57735. So we got to round that 3 up to a 4. So 5774. Sine of 120. Sine 120. 0.866, and we want to put that 0. It doesn't round up to 1 because of the 2. So just 0.866, and go ahead and put that 0 because it says 4 places. And last but not least, cosine of 95. So cosine 95, negative 0.0872, because it's going to round up. So 0.872, negative 0.0782. Did I say that right? No, I did invert it. I was afraid of that. It should be 87. Oh, I switched them. That's it. Okay, moving on. So, how do we find the area of a triangle? Okay, it is given by 1/2 the product of the lengths of the two sides times the sine of their included angle. Now remember, the included angle is the angle formed by the two sides. So it's a very simple formula. It just depends on where your angle is. So notice in the first one, if you're finding the sine of A, if you have angle A right here, then you're going to use 1/2 those two sides times the sine of A. Okay? If, it won't let me erase, if you have this angle B, then you're going to take 1/2 of these two sides. There's two sides that form the angle. And then last but not least, if you have this angle, you're going to use those two sides. Okay? It'll make sense once you do some. Okay, so look at the angle. We don't even have the third number here. And if we don't need it, don't care. Here's our angle. It's formed by these two sides right there. So all we do, area is equal to 1/2 19 times 17 times the sine of our angle, 135. And we can literally just type that right in our calculator all in one fell swoop. So 0.5, 1/2, times 19 times 17 times the sine of 135. Close parentheses. And there we go. And the area says round to the nearest tenth, so the 9 is going to round the 1 up to 2. So that means the area, excuse me, is 114.2 square units. We don't know if it's inches, feet, whatever, so we just say units. That's it. The two sides that form the angle, multiply them, divide by 2, multiply by 1/2, and then the sine of that angle. That's it. It's that simple. Now, law of sines. A little bit more complicated. Law of sines can be rewritten or written in either of the following forms for ABC. Okay, now notice, we use little a opposite big A. We use little b opposite big B and little c opposite big C. So the opposite side corresponds to the letter of that angle. Okay, and it's a simple ratio. The sine of one angle over its side, corresponding side, equals the sine of the other angle over its corresponding side, and so forth. And it doesn't matter what's on top. Letters are angles. So let's do this. Okay? So, for example 3, we have A right here. Okay? That's the only one that corresponds. That's our magic ratio. I've referred to magic ratio before. That's the one we have. Okay? So we're going to definitely use sine of 115 over 20. Because that's all we have. We have 11, but we don't have B, the angle. And then we have a little c and no big C. So C is definitely the last thing because we don't have any information on that. So basically, since we have this, we're going to try to find this right there. Well, it's just a simple ratio. It's going to be sine of B, which we don't know, over 11. And notice, we have the angles on the top and the sides on the bottom. And we could flip it upside down. It doesn't matter. We just have to be consistent. Okay? So, now we just do the math. Okay? We cross multiply and divide. Okay? So the sine of B times 20 equals the sine of 115 over 11. Well, I want to get sine of B by itself. Sorry, why did I say times 11? My bad. Not thinking. Come on, erase. There we go. Silly me. Sine of B times 11. Okay, we're multiplying like so. Now, to get sine B by itself, we're going to divide by 20, both sides. Okay? So now we just have a simple calculation. Sine of B is equal to, we're going to type this in our calculator, sine of 115. Make sure you close parentheses. If you don't, it'll be 115 times 11, and you're taking the sine of that. Times 11 divided by 20. And we get a decimal. Okay? So 0.4985. 0.4985. That's the sine of b. But remember, we don't know what the sine is. And we learned the other day, when we're trying to find the angle, we take the inverse sine. So I'm going to take the calculator now and do inverse sine of 0.4985. And it says round to the nearest tenth. So B is 29.9 degrees. That's this angle right here. Okay? Well, we can find C now, because if we add 115 plus 29.9, we get 144.9. If we subtract 180 minus 144.9, we get 35.1. So we know this is 35.1. And now we're just going to do it all over again to find this right here. Except we're going to do A and C. So moving on, do the same setup. Our magic ratio, sine of A, 115. Sine of 115 over 20. That's our magic ratio. Now, we know we know C is 35.1. We don't know that. So we're going to cross multiply and divide again. C is equal to, well, sine of 115 times C is equal to 20 times the sine of 35.1. How do we get C by itself? Divide by the sine, both sides. Now, we just type that in our calculator again. Just step by step. Whoops. So 20 times the sine of 35.1, close parentheses, divided by the sine of 115. And there we go, we get 12.68. And it says round to the nearest tenth. So that means side C is 12.7. And now we have all the information on that triangle. Okay, example 4. Same concept here. Now, on this one, we already have two of the angles, so we can just find the third angle by adding those up and subtracting from 180. So A is going to be 48 degrees. We know that. Okay? Now, what do we know? What's our magic ratio? It's this one right here. Sine of 25 over 15. Now, we can find A or C, it doesn't matter. Equals sine of 107 over C. And just to see it side by side how simple this is, sine of 25 over 15, that's our magic ratio. Sine of 48 over A. Now, since we're finding sides, we're not going to have to do any inverse ratios. Okay? So, sine of 25 times C equals sine of 107 times 15. Divide by sine of 25, both sides. So, C is equal to, take our calculator, sine of 107, whoops, I already put my pin down. Okay, again, sine of 107 close parentheses, times 15 divided by sine of 25. And that tells me that C is 33.9, because the 4 tells it to round out. Okay, same concept here. Cross multiply. So it doesn't matter what you put first. A times sine of 25 equals 15 times the sine of 48. We got to get this by itself, so we divide by the sine of 25, both sides. Cancels. So we just type in our calculator. Again, straightforward. 15 times the sine of 48. Close parentheses, don't forget that. Divided by the sine of 25 from our magic ratio. And that gives me, round to the nearest tenth, 26.4. Okay? And then as you can see, oh, one more, forgot, example 5. One more. Okay. So, we're trying to find the length of the bridge. Okay? So, a surveyor makes the measurements shown to determine the length of a bridge to be built across a small lake from north picnic area to the south. So, we're trying to find C, basically. Okay? So, we need to first find the third angle. So, 71 plus 60, and subtract that from 180. So, that would give us 49. Probably not a good idea to use blue on blue. 49 degrees. Now I have my magic ratio. Now we're just trying to find C right here. We're not looking for A, we're looking from north to south. We're trying to solve for that. So we're going to use this. So same setup. Sine of 150 over 49 equals sine of 60 over C. Okay? I think you can see enough how it goes so far, so I'm just going to skip a step and say C is equal to sine of 60 times 49 divided by sine of 150. I think I've shown enough on the calculator, you know how to use it. So C in this case is going to be 172.1 meters. And that's it.